All right, in previous videos, we went over how to name ionic compounds, simple binary ionic compounds specifically, and ionic compounds containing transition metals. Today we're going to actually cover how to name covalent compounds and get into a bit of naming involving polyatomic ions. But before we do that, I wanted to show you a funny article that I pulled up a few years ago. And it said that city officials were concerned about the dangerous properties of dihydrogen monoxide, so they considered banning foam cups after learning that it was used in their production. After they learned that dihydrogen monoxide was short for H2O, they felt pretty embarrassed. And I will say, stuff like this happens every year. People often make jokes like, oh my gosh, did you know that dihydrogen monoxide is toxic if inhaled? It's like, well, yeah, that's just drowning. It's not a dangerous situation, though, as long as you wear a life jacket and have safety stuff around your pool. But this kind of gets into the idea that we're going to cover today, though. We're going to cover how to name covalent compounds like water as their preferred names in chemistry. All right, so let's do some simple review. And we're just going to go over how to name binary. Let me rephrase this. How to name binary covalent compounds. All right, the rules are pretty straightforward. Okay, the first rule is that the less electronegative atom goes first. That one's always true. And then the other thing you want to remember is you use prefixes. To indicate the number of atoms. And this kind of sounds weird at first, but let's first make a list of prefixes and then we'll use it to apply for names. So let's do prefixes here. And then number over here, and we'll just make a nice little table here. So for one atom, it's just called mono. For 2 atoms, it's called di. For 3 atoms, the prefix is tri. For 4, it's tetra. Not quad. I see a lot of students try to use quad. 5 is penta. 6 is hexa. We'll just keep going all the way to 10. There's more than that, but we're going to stop at 10. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. So for example, in the case of H2O, right? The less electronegative atom in H2O is hydrogen. So that would go first. So I'd say hydrogen. However, we have 2 of them. So I would say dihydrogen, right? So this di right here indicates that we have 2. Okay, so dihydrogen, and then we have 1 oxygen, right? So we're going to write monoxide. We're not going to say monoxide, so we're not going to do monoxide like this because, sorry, I had an extra D there, because the 2 vowels in a row looks weird and it sounds weird. So we're just going to do an omission of one of our vowels. So avoid 2 vowels. Okay, so we've got dihydrogen monoxide, and just like with ionic compounds, we're going to chop off the suffix and change it to an IDE suffix. Is IDE, and mono right here indicates that we have 1. Okay, so hopefully this makes sense. Let's do a few more though. And let's do, so over here we did H2O. I'm going to slide this over as well. And let's do CO. So CO is 1 carbon, 1 oxygen. So we don't use mono if it comes at the very, very beginning of a name. It's just implied. So I'll say carbon, but we do have one oxygen, so I'll say monoxide. So let me do a little note. So the note is, don't include mono at the start of a name. It's implied. You do include mono over here before oxygen, but we don't include it before carbon. All right, so carbon monoxide is a poisonous gas found in your house. Well, hopefully not found in your house, but can be found in your house. It's why you have a carbon monoxide detector. It'll actually make you pass out and potentially even die if you're exposed to too much of it. So it's really important to have these detectors in your house. All right, let's try another one. N2O4. So we've got two nitrogens. So I'd say dinitrogen. And then we've got 4 oxygens. So I'd go over here and I'd look at 4 and I'd say, well, that has the tetra prefix. However, because oxygen comes next, I'm going to drop this A and just do oxide. That way we avoid the problem of having 2 vowels. So like I said, we want to have the prefixes before the element. However, if the prefix ends in a vowel, omit that last vowel if you're dealing with something like oxygen that starts with another vowel. So over here, we've got monoxide, but we're not going to include the mono here because that would be at the beginning. But over here, we're going to include both di and tetra. All right, let's do one more. Let's do PF5. So we've got phosphorus. We only have one of them, but we're not going to include mono because that would go at the start of the name. So I just say phosphorus. And then we've got 5 fluorines. So I go over here and I'd say, well, that's penta. So this would be penta as a prefix. And then we're not going to drop this last A because fluorine starts with the non-vowel. So I'd go fluor, and then I would change the suffix to IDE. So in this case, we're going to have penta, but we're not going to have the mono. Okay, and with all of these, remember to follow the same rules with the IDE suffix that we did when naming ionic compounds. It's important to keep that. All right, let's do a little bit of review though. So up above we did naming covalent compounds, but let's do naming ionic compounds. Because this kind of ties into polyatomic ions, since polyatomic ions are by definition ionic. Okay, so if you remember, if both atoms are representative elements, meaning in the S or P block, you want to do the following rule. You go metal plus non-metal with an IDE suffix. Okay, so let's take an example. And in this example, we'll just do NaCl. So in this case, like we said in our previous video, we just list sodium first. We don't say monosodium just like we wouldn't in covalent compounds. And then we're going to have a space. And then we're going to do chlorine next. But we're not going to say monochloride. We're just going to say chloride. So no prefixes for ionic compounds. I know it's kind of tricky to keep track of, but the first thing I do when I'm naming is I first say, is it ionic or covalent? If it's covalent, I remember I need prefixes. If it's not, then I ignore prefixes. They're implied. All right, so this is pretty simple here. We've got if both atoms are representative elements. But the question next is if one atom is a transition metal. And that means that we would have something from the D block. And we said that the problem previously with D block elements is it's not always clear what the charge is. So what we do is we do a metal plus a number. And this number is going to be a Roman numeral, not just a number. And then we do our nonmetal. And then we follow it up with our IDE suffix. Okay, so this is going to be a little bit different, but let's do an example just for practice. And in this example, we're going to deal with copper chloride. Well, if we break this down into two pieces, we know that chlorine, when it's ionic, is always going to be 1 negative. And the question is, well, how do I know? Well, think about it this way. Elemental chlorine has a valence of 7. Does it want to lose all 7 electrons to get to the nearest noble gas, or does it want to gain 1 electron? Well, I'd say it'd be a lot easier to just gain 1 electron, giving it an overall 1 negative charge. So we're confident with chlorine. But then the question is, well, if we're confident that chlorine's -1, what would copper have to be? In this case, it would have to be +1. Okay, so let's do the naming. So we've got copper. Sorry, I should do 1 plus, not +1. And we've got copper with a charge of 1, so I'll do Roman numeral 1, indicating a +1, or 1 plus, I should say. And then we've got our nonmetal, which is chlorine. And then our suffix is going to be IDE. So because copper is a transition metal, we have to include the charge as a Roman numeral following the metal name. All right, so the next one is, what about if we have one or more polyatomic ions? So what if we have one or more polyatomic ion? Okay, so this gets a little bit trickier, but the root of this is still going to be the same. We're still going to do our cation first. Even if that cation's a polyatomic ion, we put it first. And then we're going to go to our anion. And then we're going to have our IDE suffix. So here's the weird thing. Is a polyatomic ion could either fill the role of the cation, or it could fill the role of the anion, or it could fill both of them. So let's go ahead and take a look at some common polyatomic ions. And I'm just going to paste the table from our book, because in my opinion, that's the easiest. And I think it's right here. Perfect. So these are our common polyatomic ions. So if we look at the cations, it could be something like ammonium. So this would be a sample of a cation that's a polyatomic ion. Really, luckily, the rest of them, if we look at the rest of them, they're all anions. So for the most part, with the exception of ammonium, we're going to assume that it goes second. And I know this is kind of a weird quarter. My preference is that students memorize these. And in fact, I'm going to put some flashcards on the website to get students to just simply practice this over and over and over again. Try to go through that flashcard set multiple times and at least remember the ones that are within the set. Some of these might not necessarily be in the set. If they're not in the set, I consider them to be not as important, but I definitely want you to remember all of these over here. All right, so let's go ahead and do some naming. So in this example, I'm going to do NH4Cl. Okay, we're going to break this apart. And as you can see, we've got this NH4 in here, which means we must have an ammonium. Okay, so let's break this down into its two pieces. So we've got NH4, and this is going to be 1 plus. And then we've got chlorine, which is 1 minus. So our cation, in this case, is going to be ammonium. And we know this because that's the name listed on the chart. And then the anion is going to be chlorine, but we need to do the IDE suffix. Okay, so like I said, always put your cation first. Let's do another one. Let's do NH4NO2. And in this case, you can see there's not a metal anywhere in here. We just have to know that, hey, this is a polyatomic ion, therefore it has to be ionic. And like we said before, we can break this into its two pieces, its cation and its anion. And just like up above, this is going to be NH4, 1 plus. And then NO2. If we go up and we look at the table, we should be able, sorry, let's do NO3. I misspoke here. Sorry about that. Let's go ahead and look at where that would be. So if I look at this, NO3 is nitrate. It's NO3 minus. So let's go ahead and do NO3 1 minus. And as you can see, the 1 plus and 1 minus cancel out. So I would say ammonium. And then I would just do nitrate. You don't need to include the IDE suffix. So no IDE suffix with polyatomic ions. Okay, let's do one more. Let's do this one. This one's kind of fun. This is something most of us have in our kitchen. It's NaHCO3. This is just baking soda. All right, so again, let's break this apart. In this case, it's a little bit easier for the cation because we know it's just sodium. So it's sodium 1 plus. All right, but let's see if we can find this missing chunk over here. So HCO3. So let's go up. And if I go up here, it's hydrogen carbonate. Okay, so it's HCO3 1 minus. Okay, so we do our cation first, which is sodium. And then we do our anion next, which is just going to be hydrogen carbonate. Oftentimes this is referred to as bicarbonate as well. But I hope this makes sense. There's a lot of good practice problems in the book. I recommend working through those, especially before you do your homework and quiz. All right, good luck studying, and let me know if you have any questions.